Okay, I'll introduce myself too. So I am Amy Zhang. I am a PhD student at MIT CSAIL, and this is work that I did as an intern at Google Research, now called Google AI. With my co-authors, Jilin Chen, Wei Chai, Jinjun Xu, Lichan Hong, and SIGCHI, in collaboration with Google Play. Okay. So today I'm going to be talking about search results. This is the Google Play Store, which I'll be talking a lot more about today. And I pulled up a search for cats. And you get this big mess of returned apps, which is pretty typical of what you would see on most search engines today. Here's another example on Netflix of searching comedy. So what you get back is basically this big list of content with no organization of the items. So you have 90s TV shows next to stand-up specials, next to indie movies, etc. So this hodgepodge can be really difficult for users to navigate or make sense of. So one proposed way to improve this user experience is to have clustered search results. Particularly in an experience like mobile, this is a nice way to break up results into distinct categories. And indeed, researchers have demonstrated the benefits of having more structured search results for more kind of like exploratory searches. They add more visual cues, they make exploration easier. You can now discover interesting new categories you didn't think of. You can also ignore the clusters that you don't care about. But just as an aside, notice how old these papers are. They're all like a decade or like 2 decades old. But surprisingly, almost no real-world search result pages actually do clustered search results today. The closest thing that looks kind of similar is if you go to the home page of some sites, like Netflix here, it looks kind of like clusters, right? But here, these clusters aren't dynamically generated based on a search query, so they're a lot easier to fine-tune. And that's part of the reason why we just don't really see clustered search results in production search engines today, despite their benefits. The problem is the raw output of these clustering algorithms often have a lot of problems. And it takes a lot of mostly manual work to make sure those clusters are up to par. And this is something that just doesn't scale. Here's an example of an older search engine. I don't know if you ever use this, it's called Coherent 2, that just shows the raw clustered search results from an algorithm. And you can see that for the search for salsa, it manages to separate salsa the dance from salsa the food, but there's also a ton of these like overly incoherent, really general clusters like YouTube or learn, not really sure what that means, as well as these overlapping clusters like salsa recipe and dish. Those seem pretty similar. So I think you get a sense of why we want clustered search results, but we can't just put that raw output directly into the hands of users. So now I'm going to talk a bit about how a clustered search result in a production environment would normally be produced today. And I'm going to be focusing on observations within the Google Play Store team, a team of engineers and product managers tasked with this task of introducing clustered search results for a number of queries on their App Store page. And the way the team worked was basically, it was very expert-led. So there's a lot of back and forth between software engineers and the product team. This is kind of the workflow of how it worked. So software engineers would be implementing different clustering algorithms. They would be running them on different queries and tweaking the parameters and seeing how that looks. They would also calculate some of these kind of well-known automatic metrics of quality, such as the silhouette score, that tries to get at things like coherence within clusters or distinctness across clusters. But there was also a lot of manual inspection because these metrics didn't tell the whole story. And then the product team would also help with manual inspection. From finding the best clustered search result, they would do things like take manual steps to fix small issues or give each cluster a name before actually pushing it out to production. And so one thing that the team found out was there really wasn't a single clustering algorithm that worked well across all queries. And also there wasn't one kind of automatic metric that encapsulated quality well across the board. So that meant that there had to be a lot of this evaluation and refinement of these search results that had to be done manually. And of course, it leads to all these different issues with scaling. Okay, so now I'm going to describe a new workflow called Refinery that we called. It replaces the expert-led aspects of cluster evaluation and refinement with crowdsourcing. So for instance, you still kind of want the engineers to be the ones tweaking the algorithms and looking at these automatic metrics, but instead of them kind of manually inspecting raw clusters, which can be very tiring, the crowd could maybe take over that stuff and scale that up. And instead of product teams manually inspecting and looking for problems and fixing them, the crowd could maybe do that as well. Okay, so now I'm going to dive into each step of the crowd workflow, show you the templates we used, and also show you the experiments that we ran to validate the crowd output at each step. Okay, so the first step is evaluation. Basically, given a bunch of different clustered search results, for a particular query, we want the crowd to be able to distinguish which one's the best one. The way the crowd template looks is this. Since we wanted to optimize for scale, we elected to create tasks that evaluated an entire clustered search result at once instead of tasks that were looking at specific item to cluster pairs, because there was just too many of those. So first, crowd workers are shown the query. In this case, it is algebra. And then also we kind of have like a summary of the cluster search result. Trying to reduce information overload, mimic how it might look in production. So you kind of see the major apps in each cluster, and you also see the top keywords associated with each cluster. And then the workers can also hover over to learn more about each app. We asked users to rate each individual cluster, not so much to capture the data, but to encourage them to inspect the clusters one by one, before we asked for an overall rating for the clustered search result. Okay, so we did an evaluation of this particular template workflow. We took 120 queries that were kind of exploratory in nature and also high volume on Google Play Store. And then we had 4 algorithms, each kind of emphasizing different things in their clustering approach. And then we computed cluster search results for each query and then put them through this template with 50 mTurk workers rating each clustered search result. We took an average to get a crowd rating, and then to evaluate, we also had 2 experts from the Google team rating all the search results for 60 randomized, or we picked 60 queries out of the 120 randomly. Okay, here's a summary of our findings. So one interesting thing was that agreement between the 2 experts, was only fair, showing kind of how difficult and subjective this task can be even for experts. We also found that the crowd overall agreed with experts about as often as experts agreed with each other. And they tend to also do better when experts do agree. So the clear-cut cases when the 2 experts agreed on the search result. And so overall, the crowd annotations were providing a good signal. However, we did need to gather a lot of crowd ratings to get to that level of quality, around 40. Although in actuality, we dropped about half of the 40, so we did some filtering to filter out the people that weren't spending a lot of time on the task. So maybe you actually need closer to 20 if you do more to pre-train or pre-screen. Some other things we tried that didn't really work out. So we tried something like a side-by-side template where you can compare 2 cluster search results at the same time and see which one you like better. Overall, this didn't work well. It turns out it's just too much information. People tended to just pick the search result with more clusters, whether or not it was actually better. Okay, I'm going to move on to stage 2 of the workflow. Here we looked at giving an existing clustered search result, maybe it's the best one from the last round. Now can the crowd refine that search result to improve it? The 2 actions that we looked at are merging 2 clusters that are overlapping or conceptually similar, and also deleting incoherent or irrelevant clusters. So here's an example of what that would look like for merging. Here's the query animal. You have the clusters zoo, pet, action, and jigsaw puzzle. Makes sense. But the clusters education/learning, and there's a cluster kind of about children. They had a lot of overlapping apps, so you could imagine merging those 2 together. Here's the interface for merging 2 clusters. So we actually had the crowd workers go through and rate the quality of each individual cluster before suggesting potential merges, again, to get them to inspect the clusters one by one. And they can also suggest no merges if they think that the cluster search result is fine as is. And then to combine different workers' results, we just counted up which merge suggestions were the highest and we set a threshold. Very similar thing for the template for deleting clusters. Just to let you know, we made merging and deleting 2 separate tasks as opposed to 1 task, mostly just to simplify the task for each user as much as possible. Okay, so we did an evaluation of this stage as well. We took the same 120 queries from the last stage, took the best cluster search result from that crowd evaluation, and then fed the results through both the merge and the delete tasks in parallel with 20 crowd workers each. So from these 120 queries, 47 had clusters that at least 5 workers out of 20 wanted to merge or delete. And again, to evaluate, we had 2 experts go through and rate the actions that the crowd suggested. We also did a crowd evaluation. So we took the evaluation from our first step and used it again here to show the crowd both the before and after of the clustered search result, obviously randomizing the order. Okay, so our results, we had a bit better agreement between experts for this task. And overall, experts approved of the crowd actions. From the crowd evaluation, we saw the crowd rated the after as better 83% of the time, so that was good. And even in the cases where the rating for the after was worse, the difference was quite small. So basically this step helped the clusters either get better or stay kind of about the same in quality. Okay, so now the clustered search result has been cleaned up. The last thing we need to do to get it ready for production is to give each of these clusters a title. So coming up with good titles for clusters is not that easy. To make this step easier on ourselves, we took a shortcut, which was basically to make use of the topic keywords that were already associated with each cluster. I didn't really explain this earlier, but the way we get clusters is we have apps. Apps are associated with keywords. These keywords are coming from the app developer, the app description, user reviews. And then for a search result, we get all the apps that's returned from that search result. We get all the topic keywords associated with every app. And then we cluster the topic keywords as opposed to the apps. And the reason for that is because apps grow stale very, very quickly. So now for each cluster, we actually have a set of keywords already associated with that cluster. So given that then, we developed a pretty simple last task where the crowd workers are now going through each cluster and selecting the 1 or 2 keywords that they feel best describes the cluster and makes it distinct from the other clusters. And this was actually pretty similar to what we saw the experts doing when they were titling the clusters. So we did an evaluation of this last step as well. 20 workers adding titles from the results from the last step. And then also 2 experts going through and rating 60 randomly selected queries from the 120. And overall, experts were in agreement most of the time, and they also mostly approved of the title suggestions. Okay, now that I've gone through the 3 different steps and the evaluations of the 3 steps, I'll describe a final evaluation of this whole process. So now that we have these 120 queries, we should be able to compare the final crowd-powered clustered search result with the cluster search result that went through that expert process that I described at the beginning. And actually, out of the 120 queries, there were actually 57 of them that had gone through the expert process and were currently being dog-fooded inside Google. And we had 2 experts independently rate the 2 search results for these 57 queries and also talk about which was better or worse and why. I just want to go through a couple examples to give you kind of a qualitative sense of this comparison. So in a lot of cases, we saw a final output from the crowd that actually had a pretty high quality in comparison to expert-driven clusters. So in this case, the query is trivia, and we can see on the crowd side, we have film, logo, and music, which on the right-hand side, those don't exist. They're kind of all put together in this cluster called guessing games. Here's another one where the resulting cluster categories actually turned out to be pretty similar across the 2 cases. So the query is zoo, and we have zoo simulation games, we have educational games, and we also have puzzle games. Occasionally, we had some cases where the crowd result actually did better than the expert result, which was pretty surprising. When we looked at the reason why, we found it was typically because the crowd result had more clusters than the expert result, and the new clusters that were added were coherent and also distinct from what was there before. So this query is relaxing music. Both sides have a cluster for meditation, nature, and classical music, but the crowd one also has these clusters called insomnia, health, and lullaby. So here's a summary of our findings. So the average rated quality of the crowd powered search results approached that of the expert refined clusters. Like I mentioned, qualitatively, so the times the expert results did better, it often had to do with better titles, actually. So the experts had the ability to completely rewrite titles if they wanted to. And in the cases when the crowd did well, it was because it was able to find more clusters that were still distinct. And overall, the crowd workflow led to drastic improvements over the quality of the raw algorithms. Really quickly, I just want to mention the relative costs. So overall, we found that the refinery workflow in its current state, it's cheaper than the expert workflow, but not like crazy cheaper. It's not like an order of magnitude cheaper. However, we didn't really make any concerted efforts to pre-screen or pre-train workers or cut down costs. So I do think that a lot of the redundancy we had in crowd workers, especially in the evaluate step, I think could be pared down to reduce costs, but that's not something we did. So the approach I've outlined makes it possible to scale to thousands, but not millions of queries. That would be prohibitively costly. But there is, if you consider, a diminishing cost as you kind of go down that long tail of queries. And one thing that could be interesting is thinking about ways to reuse these refined clusters that we've created by looking for equivalent queries, for instance. Another thing that I think could be interesting, there were some things that the experts did that the crowd could not do in our crowd templates. So for instance, the ability to actually move or delete topic keywords from one cluster or move it to another cluster, or actually move individual apps. So I think in a more dynamic template where maybe crowd workers could try that and see what happens to the cluster, that could be interesting. But for something static like what we had built, it's unclear whether these changes would actually improve the resulting search results. And then the last thing that I think would be interesting is the crowd refinements that I mentioned. They don't currently, but they could potentially feed back into the underlying ontology of labels or the item to label labels in case there's something like an incorrectly labeled app. That could actually go back and improve the algorithm for future runs. Okay, and with that, I will close. Here's a summary of my talk. I want to thank, again, the folks at Google, Google Play, and Google AI for supporting this research. Thanks. And now I will be session chair. Does anyone have questions? I hope someone does, because I can't ask myself a question. Okay.
So, hi, I'm Justin Art from Pacific Northwest National Laboratory. Thank you for this talk. It's really interesting. I'm wondering what happens when you consider that apps are probably added continuously. And so how would we be able to automatically bin something into these clusters that have already been created? I guess what's your recommendation?
Yeah. So that was something that we thought of from the beginning, right? So I only briefly touched upon it, but the way the clustering is done is that it's not clustering on apps. It's clustering on these topics. So that should be more durable over time, because apps come in and out of the Play Store like every day and get updates every day. So if you have clusters of topic keywords, those things are something like classical music with relaxing music is something that should be around for a long time. So maybe you could do reclusterings over a period of time, but they would last longer, hopefully.
So you have an automatic sort of like topic assignment for an app then that that's sort of static and it assigns that, and then, okay, that makes sense to me.
Yeah. So basically the app developers can add tags to their app I think there's also within within Google there is an automatic step where items are assigned labels based off of like reviews or the app description, so things that the app developer wasn't necessarily tagging. And I'll just mention like these sites like Netflix and Amazon and Etsy, et cetera, like they have these really rich tagging ontologies of things that they're using on the homepage and for doing recommendations. So we think that it could be useful for clustering search results as well.
Thanks.
I think we have time for just one last question.
So you mentioned that you use basically the tags in order to represent the items and then do the clustering. But these tags were represented like with the traditional TF-IDF or actually like neural embeddings or something like this.
I can't really speak to that because that wasn't really what I did in the project. I mean, there is like a team inside Google that does the item to like keyword mapping, and there is a lot of stuff like I think there's like a DBpedia type of like ontology where there's a database where they're doing this. So I can't really speak to it, but suffice to say that it happens. Yeah.
Okay, thank you.
Yeah. Sorry, I don't know more about that. Okay. Thank you.